Here is another example on inverse variation. And the question says, the pressure P of a given mass of gas at a certain temperature varies inversely. Let's underline that. Varies inversely as the volume V, and the pressure of a gas is 4 times 10 raised to the power of 2 Newton per meter square when the volume is 8 meter cube. We have to calculate the pressure when the volume of the gas is 4 meter cube, and we have to leave our answer in standard form. Solution. We interpret the question, the first part of the question first, which says P varies inversely as the volume, that is, P varies as 1 over V. So, therefore, that means we include our constant of variation. So that means P equals K over V. So, where K is a constant. So, same thing here, we try to find the value of our K first by using the two values of the pressure and volume that we were given at first. That is, when P equals 4 times 10 raised to the power of 2 Newton per meter square and V equals 8 meter cube. So we'll be having, when you put it inside this equation, we'll be having 4 times 10 raised to the power of 2 equals K over 8. And here, this is same thing as over 1. We can cross multiply. We have 1 times K. That gives us 1K, which is the same thing as K. So we have K equals, now we'll multiply these two together. 4 times 10 raised to the power of 2 times 8. And here we'll be having 4 times 8, that's 32, times 10 raised to the power of 2. But we are trying to leave this in standard form. So K is going to be, this is simple as having 3.2 times 10 raised to the power of 1 times 10 raised to the power of 2. We can apply the law of indices there. So we have K equals 3.2 times 10 raised to the power of, add up the powers, 1 plus 2. 3.2 times 10 raised to the power of 3. That gives us our constant. And the formula becomes P equals 3.2 times 10 raised to the power of 3 over V. So now we can find the pressure of the gas when the volume is 4 meter cube. So we just have to impute V as 4 meter cube here. So we have P equals 3.2 times 10 raised to the power of 3 times 4. And here we have 4 goes there 1. 4 goes there, we have 0.8. 0.8 times 10 raised to the power of 3. But we are trying to leave it in standard form. To leave this in standard form, the value here has to be between 1 and 10. But this here is already less than 1. So here we do 8 times 10 raised to the power of 2. Why? Because I use the decimal points, I moved it 1. So we have 8.0. So that reduced the number of zeros that we have here. So we have 10 raised to the power of 2 Newton per meter square. And that gives us the value for our pressure when the volume is 4 meter cube. Thank you.